to use technology to show you how to conduct a hypothesis test about proportions. So in this case, we're told 17% of all college students volunteer their time. Is the percentage of college students who are volunteers smaller for students receiving financial aid? Of the 362 randomly selected students who received financial aid, 58 of them volunteered. What can be concluded at a 0.05 level of significance? So what test should we use? Well, we're not testing about a mean, we're testing about a proportion. So we want to use a z-test for population proportion. In order to do that, we need that NP and NQ should both be greater than or equal to 5. Now with N equal to 362, that's N, and P, the claimed proportion, equal to 0.17, then when I look at NP and NQ, they are both indeed greater than or equal to 5, so I'm good to go with this test. All right, so now we're going to state H0 and HA. H0 will always have the equality in it. So in this case, H0 is P for proportion equals 0.17. The population proportion is 0.17. HA, the alternative hypothesis, the one we're testing, the claim we're testing, is that that percentage is smaller for students receiving financial aid. So smaller is less than 0.17. Okay, so we need to know whether this is a left-tailed test, right-tailed test, or two-tailed test. The direction of the inequality in HA will tell you what kind of test you have. In this case, it's a less than, so I have a left-tailed test. All right, so now we're going to compute the test statistic and the p-value. Now there's a formula for the test statistic, but we're not going to use it because we're going to use technology instead. But that's the formula right there. So if you come over to these list of calculators from LibreTexts and click on hypothesis test for a proportion, you will get the right calculator. And we're just going to enter what we have here. N is 362. X, the number of successes, would be the number of students that volunteer, that's 58. And the claimed proportion is 0.17. And again, this is a left-tailed test, so I want the less than checked. And I hit calculate, and I get both the test statistic and the p-value. So to 3 decimal places, the test statistic is 0.495, negative 0.495. All right, and on our standard normal curve, let's say that that's about here. The p-value is computed by looking at the area to the left of that test statistic. And again, we don't have to do that by hand. We've got a calculator that will do it for us. In this case, to 4 decimals, the p-value is 0.3102. Now, this is the probability that if H0 were true, and we sampled another 362 students, we would get a test statistic as extreme as the one we already got. So 31% is actually a pretty high probability. Based on this, what should we do? Well, we're going to fail to reject H0. And the rules are, if P, your p-value, is less than the significance level, you reject H0. And if P is greater than your significance level, you fail to reject H0. So in this case, 0.3102 is bigger than 0.05, so we're going to fail to reject H0. Essentially, that means there's just not enough evidence to conclude that the proportion of students who volunteer is less for students getting financial aid. And so if we look at our options for the conclusion, we want this middle one. The population proportion is not significantly lower than 17% at alpha equal, there's an alpha there, 0.05. So there's insufficient evidence to conclude that the percentage of financial aid recipients who volunteer is lower than 17%. I hope this was helpful.